Now let's just see the next question. Question number 3, which says that if a line intersects the two concentric circles with the center O at A, B, C, D, prove that AB is nothing but is equal to CD. So this is exactly the figure that we have over here, which is related with the question number 3. And you can see over here that this is nothing but a particular line that we have, and this line is intersecting the two concentric circles whose center is nothing but O at the particular points A, B, C, D. You can see all by yourself. And now we have to prove that AB is actually is equal to CD. So what is AB? AB is nothing but a portion in between these two rings, and CD is nothing but a portion in between these two rings, and we have to prove that this portion is actually is equal to this portion. So let's just start with it. But first of all, I'll do a little bit of construction over here, that I'm just drawing a perpendicular from this center O to this two chords, which is nothing but BC and AD. As you can see all by yourself that BC is a chord, AD is a chord to the circle, inner one and the outer one. So if I'm just taking this as nothing but a circle C1, and if I'm just taking this as nothing but the circle C2, so since we can see over here, since for C1, BC is a chord, and if let us suppose if I'm calling it as N, and if ON is perpendicular to BC, then BN is equal to CN. Why so? Because we know that the perpendiculars drawn from the center to a chord always bisect the chord. This is nothing but a theorem that we already have done with it. So Bn is actually nothing but is equal to Cn, and in the same way we can say that, let us suppose Bn is equal to Cn. So let us suppose if I'm calling it as 1. So similarly we can proceed further for the second circle. Similarly for C2 ON is perpendicular to AD. Hence we can say that AN is nothing but is equal to DN. AN is nothing but is equal to DN by the theorem again we can say. And what is that theorem? The theorem which I have written over here. Let us suppose if I am taking it as nothing but 2. So let's just subtract the two equations. Let's just subtract equation number 1 from 2. So I'm just subtracting equation number 1 from 2. So we can say over here that AN minus BN we are getting, and DN minus CN we are getting. So if I'm just subtracting AN minus BN, what is the meaning of AN? AN means this whole length, BN means this whole length. If I'll subtract this length from the whole length AN, so the only portion that would be left out is nothing but this portion. And similarly, if I'll subtract CD portion from the total DN portion, then the CN portion from the total DN portion, then what length would be left? This length would be left only. This is nothing but the side, or we can say this is the only portion that would be left out. So hence what we can say over here, AN minus BN is exactly nothing but is equal to AB, and DN minus of CN is exactly nothing but is equal to CD, or we can say that it is nothing but DC. So let us suppose if I am writing it as CD. So this is nothing that what we have to prove over here. So hence it is proved that at the end what we are getting these two portions as equal to each other, means AB is nothing but is equal to CD. So this is all about the question number 3.